Hello everyone, this is Rupa, working as an assistant professor in Kokaraju Rangaraju Institute of Engineering and Technology. Now I will discuss about multidimensional data model in data warehousing. Before going to discuss about multidimensional data model, we need to see why separate data warehouse is required, and from tables and spreadsheet to data cubes, and finally the schemas available in multidimensional data models as star schema, snowflake schema, factor constellation scheme. First we will see why we require separate data warehouse. Generally, we have two systems are available as online transaction processing and online analytical processing. To promote the high performance for the both the systems, we can see some of the things required here. For a database management system that is tuned for online transaction processing. Okay, here we have access methods are available, indexing, searching, concurrency control, recovery management are available with database management system. When we go for the warehouse that is tuned for the online analytical processing. OLAP. Here we can go for applying as a complex OLAP queries, computations, multi-dimensional view, consolidation and summarization all are available within the warehouse. Okay, in the next video I will explain about the OLAP operations. If you use the OLAP in operational database management system, it will obviously degrade the performance. And why? Because the OLAP supports the concurrency and recovery management. If we can apply this for the warehouse, it reduces the throughput of the data warehouse. That's why when we go for using as a decision support system, it will require the historical data, but it is not available with the operational database. The decision support system requires the consolidation of data from the heterogeneous sources, but operational data contains only raw data. When we go for making any of the decision support systems, it requires the consolidation of data from gathering from the multiple number of heterogeneous sources. But when we go for using it as a database, it contains only raw data. The two systems support quite different functionalities. Database management system will give different functionalities compared with the data warehouse functionalities. That's why we need a separate data warehouse. Next we will discuss about from tables and spreadsheet to data cubes. We have a table data has to be available and spreadsheet type of data is also available. Why we are moving into data cubes? Why? Because in data warehouse that obviously follows the OLAP tools are based on the multidimensional data model, which views data in the form of a data cube. Okay, the view of data in data warehouse is a cube representation. A data cube allows data to be modeled and viewed in multiple dimensions. That is, data cube is defined by different dimensions and facts. The dimension here we can call it as a dimension tables and fact table. Dimension tables such as item, time, like that. Each and every dimension table has to be contain their own attributes as item, name, brand, type, and like that. When we go for the fact table, it contains the measures such as dollar, sold, unit, price, and it also contains the keys to each of the related dimension tables. The physical structure of a data warehouse is in a data cube. The physical structure of data warehouse is data cube structure. The data cube provides the multidimensional view and allows the pre-computation and fast accessing of the consolidated data. Okay, because of this cube view in a multidimensional view, it allows for the pre-computation of data and fast accessing of the consolidating data is available with the help of the data cube. So let us go for a simple example. Here, all electronics company may create a data warehouse to keep records of sales with respect to 4 dimensions as item, time, supplier, location. Each dimension may associated with a table that we can call it as a dimension table. Example, item is one dimension. It contains item, name, type, brand, like that. And a data cube organized around the central theme as a fact table. Okay, the fact table is a sales fact table. It contains the measures as dollar sold, unit sold, and it contains the keys also. Keys of all the dimension tables. In data warehouse, data cube is n-dimensional and it is a combination of dimensions and fact tables. Before multidimensional data model, let us see how the cube has to be there, how the structure of the cube has to be available. Generally, in data warehouse literature, a data cube is also referred as a cuboid. Data cube, we can call it as a cuboid. For a given set of dimensions, we can generate a cuboid for each of the possible subsets. Level by level, we can construct the cuboids. The result would form a lattice of cuboids, which shows the data at different levels of summarization, just like as a group by operation. The resultant lattice of cuboids is called as a n-dimensional data cube. The cuboid that holds lowest level summarization is called as a base cuboid, and topmost level of cuboid we can call it as apex cuboid. Okay, it contains a base cuboid and apex cuboid. Topmost level we can call it as a apex cuboid, and the lowest level we can call it as a base cuboid. The lattice of cuboids forms a data cube. Finally, all the lattice of cuboids we can call it as a data cube. Let us observe this diagram. We have the topmost 0 dimension we can call it as a apex cuboid, and the lowest level we can call it as a base cuboid here, and we have a dimensions as a time, item, location, supplier. Okay, and that comes under the one dimensional view. When we combine the 2 dimensions, so it comes under the 2D cuboid. We can combine the time, item, we can combine the time, location, we can combine the item, location, we can combine location, supplier. Like that, it forms the 2D cuboid. In the same way, we can combine other subset, other level is a 3D cuboid. Can combine the item, time, and combined with the location. Here already item is available. The 3 will comes as a time, item, location. Like that, we can combine the next level as a 3D cuboid. And finally, all will together, it will forms the 4D cuboid. Okay, like this, the structure of cube has to be available within the data warehouse. Now we'll see the multi-dimensional data models. Okay, within this multi-dimensional data model, obviously it contains the dimensions and measures. First, we will discuss about the star schema. We have 3 types of schemas are available: star schema, snowflake schema, factor constellation. First, we will discuss about the star schema. Within the star schema, it is a popular and commonly used model. Data warehouse contains large central table containing of a bulk of data with no redundancy is called as a fact table. Okay, the central table within the star schema we can call it as a fact table, and a set of small attendant table, one for each dimension, is called as a dimension tables. Central table we call it as a fact table, and a small subset of small tables we can call it as a dimension tables. This schema will look like as a star burst with the central fact and surrounding with the all the dimension table. That's why we can call it as a star schema. The fact table contains the key attributes of the dimensions. It contains the measures along with the key attributes of the dimensions. Okay, let us go for the example of this one. Okay, within the all electronics company, we have a dimension tables as item table, location table, branch, and one more is a time, and the fact table is a sales fact table. Okay, this fact table has to be contain the keys of all the dimension tables along with the measures. Here these are the measures: unit sold, dollar sold, and average sales. These are the measures of the fact table, and for each and every dimension table contains a unique key. That key has to be available with the fact table. With this key only, all the dimension table has to be connected with the fact table. Item, it contains the corresponding attributes. In the same way, location also contains the all the attributes. These all the dimension tables are the denormalized tables. Okay, we have one fact table has to be available and surrounded by the all the dimension table. These dimension tables are denormalized dimension tables. Okay, next we can go for the next schema as a snowflake schema. Within this snowflake schema, that will be the refinement of the star schema. In this, some dimension tables are normalized into the set of smaller dimension tables. That means further the tables has to be, the data and the tables are splitting into the additional tables. Okay, normalized dimension tables are available within the snowflake schema. Single fact table with multiple normalized dimension tables forming a shape similar to the snowflake. Here we have a single fact table has to be available and multiple number of dimension tables. Again, the dimension tables are splitting into the further tables. To reduce the redundancy, this model kept as a normalized form. Okay, when we go for using as a star schema, it contains a denormalized form. It is a normalized one. Snowflake schema is a normalized one. Let us go for the example. The same thing. We have a fact table as a sales fact table. It contains all the keys of the dimension tables and measures as a unit sold, dollar sold, and average sales. Okay, here we have a item dimension table has to be available. It has to be normalized into, we have a item key, item name, brand type, and again we have some supplier data has to be available. That is divided into other table as a supplier key and supplier type, and this key has to be available with the dimension table as an item. The main dimension table key has to be available with the fact table. Okay, in the same way, the location is also. Location contains the location key, street, and it contains city information also. The city has to be normalized and it is divided into other table. The city has to be contain city name, state, and country. Okay, this key has to be available with the location table. The location key has to be available with the fact table. Like this, it contains the normalized tables within the Snowflake schema. It contains a single fact table and multiple number of normalized dimension tables. Okay. Then next last one is a fact constellation schema. This is has to be used with the sophisticated applications may require multiple fact tables to share multiple dimension tables. Whenever we require a multiple number of fact tables and multiple number of dimension tables, we need to go for using as a fact constellation schema. Multiple fact tables with multiple dimension tables has to be available within the fact constellation schema. It can be viewed as a collection of stars. That's why we can call it as a collection of stars, or therefore we can call it as a galaxy schema or fact constellation schema. Within this fact constellation schema, it contains the multiple number of fact tables and multiple number of dimension table. It looks like as a collection of star schema. Let us go for the example. Within this one, we have a two fact tables has to be available. One is a sales fact table and second one is a shipping fact table. Okay, and whatever the fact table has to be available, it contains the keys of the dimension table surrounded by it, and it contains the measures also. In the same way for the shipping table also, it contains the keys and it contains the measures. Okay, here the dimension tables has to be shared with the any of the fact table. Okay, here for example, location is available with the fact table, sales fact table, and it is available within the shipping fact table also. That means the shipping fact table is also requires the location information. In the same way, the sales fact table is also requires the location information. That's why these dimension table has to be connected with the multiple number of fact tables. This is about the multi-dimensional data model. Okay, here we have a star schema, Snowflake schema, fact constellation schema. Within the star schema, we have one fact table and multiple number of dimension tables. And Snowflake schema, we have one fact table and normalized dimension tables. And finally, in fact constellation schema, we have multiple number of fact tables and multiple number of dimension tables has to be available. Thank you.